Are more expensive cables actually better? I have a few examples here. These are XLRs, and I'm going to do a few different tests for you. So let's go. So I unpacked all the cables so I can tell you a few words about them. So first, you can check the elasticity. The more elastic the cable, the better it is probably. Most renowned companies use nitric plugs, and they're very high quality. So this is something you can also check. Hycon also seems very nice, but some very cheap cables use plugs that you can instantly feel are a bit more rough when you touch them. So this is something you can look at. Also, these elements here are mostly plastic and not rubber, while when you take some more expensive cables, usually you have some nice rubber here, like nitric, and it also makes the cable less prone to breaking. Most cables are OFC, which means oxygen-free copper, and well, you can just check on the cable, on the packaging. If it doesn't say OFC, it doesn't mean the cable isn't OFC, but this is something worth checking. And also sometimes such elements like this may be a little bit rough or clicky. With high quality, it should work well. So that is basically it. When you use cables a lot, you plug and unplug. The quality of plugs is kind of one of the most important things, and also how elastic the cable is. The cheapest one tend to be a little bit less elastic. First, I'm going to connect the output of the RME Babyface Pro FS with the input, microphone input of the Discrete 8 from Antelope Audio. These are truly great studio interfaces. So first I set the maximum gain in my first mic input, which is 65 decibels. So as you can see, when I boost the mic pre's, the level of noise raises, and now I'm going to boost it even further by 24 decibels using a stock compressor. So I've got sample-accurate recordings of the same loop, synchronized in a digital way. It couldn't be more precise, and let's listen if you can spot any difference. So we were listening from the cheapest to the most expensive cable, and I couldn't hear any difference. Of course, you're listening to the MP3 file probably on the YouTube or elsewhere, but honestly, I was listening to like 15 or 20 minutes and I couldn't hear any difference because they are just too subtle. But there are very small differences, and I'm going to show you what these are. Okay, so I'm going to make it now 10 million times louder, about 72 decibels. 3 decibels is like twice more acoustic energy. So if you make it 6, then it's like 4 times louder, and you know it's logarithmic scale. So it's huge difference, and we'll actually be able to hear the difference. But it's only like it's only an experiment. You won't hear it in real life. So now I'm going to boost the signal on my summing bus using compressors, and these are actually work as gain boosters. So As you can see, I set the threshold to 0, which means that the compressor will stay inactive, and I just set the makeup gain to 24 decibels, and having 3 of those guys here just means that I get a total gain boost of 72 decibels. So I can now switch one of those signals to solo. Let's say it will be this one. I face flip it, and then I can compare it with the signal recorded with other less expensive cables. And the bigger the difference, you can assume it's probably for the worse, but actually you can hear if anything is taken or added, though you cannot say what is added and what is being subtracted. Anyway, let's hear the differences. Bigger difference, much smaller difference. Again, bigger difference. And actually, comparing those two, you can hear lots of high frequency, which might mean that the stack cable is probably a little bit duller, or it may be a little bit sharper. But the differences are so small that I can only hear them if I boost the signal by 70 plus decibels. So it is really negligible. And of course, you get some noise, because noise is random, and you can you really control it or phase flip it to cancel it. So this experiment just shows that there are some differences. And if I choose other cable, probably a good one like SSQ or Summer Basic, you can also hear that the differences between those cables and less expensive cables are bigger than with others. Now I am going to make one more experiment. I bundle these cables like this, and I am going to put them around some, cables, AC outlets, adapters, computer, monitors, strong magnetic field, and we'll see if their shielding works the same way. So I boosted the mic pre. So I set mic gain at 65 decibels, which is the maximum. Also, I boosted the signal on my PC using 2 compressors, so it's around 36 decibel of another gain, additional gain. And now I'm going to show you the interferences starting from the most expensive cable to the least expensive one. So let's start. This is cloth cable, minus 27.3 probably. Yeah, summer cable, around the same, minus 27.1 or 0. Then we've got Hossa cable, which is actually 3 times less expensive than the cloth cable. And the results are quite similar, minus 27.2. Then you've got sound station quality cable, and the result is also very good, minus 27.1. But then when we move to less expensive cables, then you might expect some more interferences, like some DC, and you've got harmonics here, so it's minus 26, minus 25.9 for the Rockstone Pro L. it measures quite good, minus 26.8. And then we've got stag cable, and this one is significantly more prone to some electric interferences, minus 24.5. So even though it's only 2 decibels, 2 LUFS units, you can hear and you can see it on the meters. All right. My final thoughts, I made some notes. So, comparing different cables, cheap and expensive ones, I couldn't hear any difference on a one-track basis. So, actually there is no noticeable sound difference between different cables. So it seems like everything matters more than cables, like your studio acoustic, your monitors, your DAs, converters, your preamps, etc. However, if you sum 2 signals coming from different cables and you flip one in phase, they do not cancel each other completely. Of course, there will be some noise, but also you could hear some parts of the signal. And the cheaper the cable, the more high frequencies you will hear. And probably it means they have higher resistance and higher capacitance, and they just are worse when transmitting those super high frequencies. But you know, probably you won't hear a difference unless you have like either 50 cables, 50 tracks, or maybe you have like 50 meters of such cable. Then it might be noticeable. However, I would strongly advise you not to go for cheapest cables. Why? Because usually you have no information about the quality of the cable. You have no information about resistance, capacitance, the copper quality, etc. So you really don't know what you're buying. Also, mid-range and high-end cables manufacturers provide some kind of warranty. Sometimes it's a lifetime warranty, so it's worth to consider. Also, if you choose a mid-range or high-end high-priced cable, usually they're equipped with better plugs, and better plugs also means healthy studio equipment. If you plug and unplug very often, it probably make a difference, like in 5 years or 10 times your preamps won't break and it will work just fine. And also cheaper cables are more susceptible to noise and to mains hum. And that's about it, I think. So there are very small differences between cables. If you sum them and phase flip, you'll get like minus 100 LUFS difference, but it's really negligible in most cases. So just choose good cables, check parameters, and if you're not running 10 meters or 20 meters, you should be fine. So that's it from me. Don't forget to subscribe, and I'll see you soon.